Or what is in a helium nucleus? Only protons and neutrons. What of those have a charge? Only the protons. And if you look at helium in the periodic table, it's just here behind my board, or you can look at that, you can't really read that one. Just here behind my board, helium is in group 8, the first one, so it's got 2 protons. If we give you a question like this in the test on Friday, which we won't, but if we give you a question like this in the exam, we need to tell you what the charge is on a proton, because, or how many protons, we don't have to tell you the charge on a proton, we have to tell you how many protons it has, because we don't give you a periodic table in the physics exam. You only get a periodic table in the chemistry exam. So we would have to tell you that an alpha particle is a helium nucleus with 2 protons. All that information we would have to give you. Yes?
Do you have the sheets?
Has it been that long for you?
Yes. 2 weeks.
It must be like a culture shock for you to be back at school, right?
Yes, ma'am, it's not normal.
No, this is normal. Everyone else has, right? Okay. And they told you, guys, that these are separated by a distance of, they gave you the distance there, 4 times 10 to the minus 13. And it was already given to you in meters, so you don't have to worry about conversion. Am I mixing my questions again? I can just look at it there. 3 times 10 to the minus 9, still in meters. And guys, they said there are 2 alpha particles. So what will the charge be on this alpha particle? Exactly the same. So it will also be 2 protons. Where do we get the charge on a proton? So that's the first thing. So this will be my Q1, and this will be my Q2 that you're going to substitute into your equation. So to get that charge, where are you going to find it? Same as an electron. So go and look on your pink sheets. What is the charge there? Oh, so it's going to be 2 times the charge on a proton. We used it on Friday as well. Oh, no, not Friday. Thursday. Did you remember that? 1.6 times 10 to the minus 19 coulombs. And this one will be the same thing. So both of them will have that charge. Now we need to see what is the question asking us. So the question is saying, what is the force? Go to your pink sheet again and look for the equation for force. Good. Are you all finding the right one? F is equal to K, Q1, Q2 over R squared. And then you just go and stick in all those values. K, we have already. It's 9 times 10 to the 9. Am I right? Please don't mix up the constants, guys. So it's 9 times 10 to the 9 times by these 2 charges, which is 2 times by 1.6 times by 10 to the minus 19 for Q1. But because Q2 is exactly the same, what can I do here to save myself some writing time? Careful, because now I can see why you want to do that. Because he's saying it because there are 4 protons in total. But here, there's 2 here, and we already put the 2 there. So we have to take this charge and times it by the same charge. So that's why we would square it. Otherwise, you can write that whole bracket again. It's just because the Q1 and Q2 is equal to each other this time. So it's like having a 5 here and having a 5 here. So it's 5 squared.
So now, 2 times 1.6, is that the
Yes, because the charge is 1.6 times 10 to the minus 19 on one proton. But a helium nucleus has 2 protons. And so this is the charge on one alpha particle, but then the other Q is also an alpha particle. I want you to get used to this because sometimes Q is the unknown. And then you forget that if they're the same, I can just square them and the math becomes easy. So please remember that when you have the same charges, you don't have to write them both. You can just say Q squared over R squared, and we have that value is 3 times 10 to the minus 9 squared, and now it becomes calculator work. Everyone, calculators out, please make sure you get that answer. There is no answer. So you need to tell me what the answer is. Tell me what it is. 1, comma 0 into the minus 10 newtons. Are you ready, you guys? You should all be getting 1.024 times 10 to the minus 10. Did you get it now right? Guys, you really need to invest in calculators. It doesn't have to be a silver one. You must borrow one if you don't have one.
Maybe the silver one, I think
Just check if your mode operates.
it's fine now. You probably did this. No, I'm gonna go. You
Let me tell you one. Guys, you all find the calculator now. 1.024 times 10 to the minus 10. He was doing, he was watching. Otherwise, he learns nothing. You two come up, you get it now. 1.024 times 10 to the minus 10. Oh, go shift mode. But choose 3 or 4. Don't choose 1. That's why it's better to ask the real teacher, not the fake teacher. You guys, come, shh. It said calculate the force between this grade 11th. It said calculate the force between these particles, not the magnitude of the force. So do I get any marks for that answer that I wrote there in the corner? No, not even one, because I didn't even write newtons. So you have to write the unit still, but you also have to say in which direction. So the force, remember, a force is always between particles. So which direction is this force going to pull them if they are here? Towards each other. You can say attraction or you can say towards each other. It really doesn't matter, but you must put a direction. Where are you from? Oh, yeah, why am I even saying attraction? I'm just listening to people. If it's a positive charge and a positive charge, what will they do with each other? So it will be away from each other. Sorry, I didn't write that. It's away from each other because they are the same. So you don't have to worry about the charge until you worry about the direction. So it will be a repulsion force. Okay, now B, guys. They say, what will happen to the charge if it was replaced by electrons? Now it's a ratio question again. Please do not waste your time to go and do this whole calculation again. You know that Q1 is now not 2 times 1.6 times 10 to the minus 19 anymore. It's just going to be, what's the charge on one electron? 1 times 10. So Q1 is going to be half of what it was. Q2 is going to be half of what it was. You really can go and put all the values in if you really want to, but it's such a waste of time, yes. Because the charge on one of these alpha particles was 2 times 1.6 times 10 to the minus 19. Now it's going to be 1 times 1.6 times 10 to the minus 19. Because the charge on one electron is just
2 electrons.
Oh, okay, wait, let me draw it. I see the confusion, don't worry. Okay, so a helium nucleus and a helium nucleus. This was 2 protons, right? And this was also 2 protons. Now we are replacing them here with 1 electron, right? And another electron. So they say the alpha particles were replaced by electrons. An alpha particle consists of 2 protons, has been replaced by an electron. This alpha particle that was 2 protons was replaced by 1 electron. It didn't say they were replaced by 2 electrons each. It said the alpha particles were replaced by electrons. So instead of an alpha particle, I now have an electron. What happened to the charge from there to there? It's halved. You're not really worried about the fact that it's positive or negative until you get to the direction. This one was also halved. So if both of them are halved, what's going to happen to the force? Remember, if you're going to guess, rather don't and use the equation. K, Q1, Q2 over R squared. Is Q1 still Q1? No, it's half of what it was. Is Q2 still Q2? No, it's half of what it was. So here I must times by a half and another half. What do I get? 1 over 4. So it's going to be a quarter of what it was. So this new force will be 1 over 4 of what it was there. But is that the only thing that's going to change? What about the direction? Is that going to change? It's still going to be a repulsion because they were 2 pluses. Now they're 2 minuses, so it's still going to be a repulsion force. So the only thing that's changing is that the magnitude will be a quarter of what it was. Okay, I really want you to do number 4 first because now it's getting now it's vectors. So please, I need you to do the free. I think this one actually asks you to do the free body diagram first. If it didn't ask you, please remember to do it in the test on Friday and in the exam and forever. If you're not sure about forces, draw the free body diagram. Normally in an exam, we would give you a diagram. This one was a bit mean because they didn't. But they did tell you that the charges are in a straight line, Q1, Q2, and Q3, and they give you the distances. So draw a little diagram for yourselves. If you can do this question, one of the questions in the test would be very easy for you. Please shout me need help. Guys, please remember that if the question doesn't speak about gravitational force or tell you mass, then you can assume that the only forces are these electrostatic forces. Yes. Because for me, I was trying to make a lot of actually. So just for one, that one, two, illustration. And I actually kind of like that. I'm just. Oh, Brandon, I keep on forgetting to tell you guys. Parents' evening tomorrow. I didn't have any of you wanting, your parents wanting to see me. No, it still says the squad. But it has been changed last week. When though? It's still when.
They're trying to make it look in.
Because it's going to close tonight. So I'm going to otherwise, it is entirely not just yes, okay, now, yes, so now the first question Okay, so now you have to say, I'm Q2. Q2 is a power what is it? Is it plus or minus? Plus. Right? So what is the plus? For without the label Q2 without sign. Anyway, ignore that. Now that I'm going to put 1, 2, because I'm just between 1 and 2. Can you ignore that one? Right now, what is this? So we place Q2 is on Q2. I like Q2. We place Q2 I'm putting it this way, and putting it this way. Anyone else need help? Well, I just think if you can ignore it, it's a free one guy, but if you put it down. Yeah. Are you all done, guys? Okay, but you're done with the diagram, right? Please, you need to read these questions very carefully. That's where you're going to lose marks if you don't read. They're asking you for question for A, draw a free body diagram showing the forces on Q2. Please make sure you force yourself to highlight the one that they're asking you about. Because now if we look at, I would call this force here F1, 2. Please remember in a test that's not enough. You have to say force on 2 or between 1 and 2. That's fine. But for a free body diagram, we have to label our diagrams. F1, 2 is a force I made up. Then you must have a key. So F1, what I mean by F1, 2 is even if you write 1 of 1 on 2, that's fine, but you need to describe what your force is. If your label is not proper, the only ones you can abbreviate are the ones that's on your information sheet, FG, FN, those ones, not one that you make up yourself. Okay, so the force here is between 1 and 2. Now you need to think, if I draw a free body diagram for 2, 2 is going to be my dot. So which way will this F12 be pulling 2 if this is positive and this is also positive? To the left or to the right? Okay, so you're all agreeing it's to the right. So F1 on 2 will be pulling it this way. But then we've got another force acting on 2 because there's also a force between 2 and 3. So again, I would say that's F2, 3. You can call it what you want really, but just say what you're calling it. Now, which way will this force be pulling Q2 if this is positive and this is negative? To the right. To the right again. There's no angle. Lots of you want to put in angles. You're making it harder than it is. It's not that hard. They said in a straight line. So this is F2, oh no, 3 on 2 because we're worried about 2. Putting it that way. So there's my free body diagram. Remember also, we give you the mark allocation. So this question will count 2 because there are 2 forces. In a free body diagram, the mark allocation always tells you how many forces you must draw. It's a hint for you. But now for B, yes.
Is the dropping even like in a line, like the arrows of both points to the right? Like you put the F1 like on the other side.
It is wrong. Guys, listen, this is important. If the old force diagrams, it didn't matter. So did you do it like this and like this? Is that what you did? Okay. So if this was a force diagram that used to be asked, F1, 2, F2, 3, this would be marked right. But because a free body diagram has a rule that says you have to draw all your arrows away from the object. That is why you can't do it, because this arrow is pointing towards your object. So that is why you have to take your object and pull and draw them both away. Although the science is right, if it's specifically, so if you were just drawing it to help you with your question, that's fine. But if it's specifically asking for a free body diagram, all the arrows must point away from your object, otherwise it's wrong. Okay, then for B. They say, what is the net force? Net electrostatic force. So you can ignore weight, guys. Net electrostatic force. So what are you going to do to get F net? You're just going to add these two forces. It's going to be F12 plus F23. Oh, and now it's going to be so much writing and calculator work. Have you all got the answer already? I hear all kinds of different answers. They could, well. But put it in scientific notation. Must I write this all out, guys? I'm going to need a whole page. Are you getting it? Yeah. Then you would have to see which one is the bigger one, and you'll take winning force minus losing force. It's the easiest way to remember it.
So now you can just make
Guys, please remember you get a mark for the equation. So at least once write the equation down. K Q1 Q2 over R squared. Before you start with your substitution.
No, F33. Oh, G23.
In the question, they said aggregate small q's, so you put that in the formula with the time.
Yep, small q, big Q really doesn't matter.
That's Still no question.
Guys, if you can do question 5, you are overqualified for the test on Friday. Overqualified. No, we still, it's taking me forever to write this down. Do I really have to carry on? It's quicker for you guys. Is it 10? Can't be 10. I would really. Because now I already got the mark for substitution, so that's another mark. Oh man, I can't do this. My board's playing weird games. Okay guys, please remember you are not, because we've already decided they're going in the same direction, you're not going to put the minuses in the calculation because we're getting the size of our force now. By doing this here in the free body diagram, you already decided which one is attracting and which one is repelling. So in your calculation here, you're not going to put a minus at the 3. Because then you're going to minus it instead of plusing it, which is going to be wrong because they're acting in the same direction. That's why sometimes it's safer to work out the one force first, then work out the other force and then add them up. But whichever way you want to do the maths is fine. Okay, now you have to put all of that in your calculator. And then what did you get, Tabang?
6,19 times 10 to the negative 5 meters.
Yeah.
Times 10 to the?
Negative 5 meters. And I took the direction towards Q3. Is that right? We take those to the right.
If you have a diagram with it showing to the right, you can say to the right. So you can always refer to your own diagram, and I think most of you drew diagrams. So if you said towards Q3, that would be perfectly right for this one. But you could also, if you drew a nice diagram that we did, like this one that we drew here, on your diagram it's clear that it's to the right, then you can say to the right. That's why it's always beneficial to draw a diagram. See, now there's 2 things. There's weight as well. This time they did not tell you to ignore the weight. Is this mine or yours? Yours. All right, they're telling you 5-gram point charges. So both those little balls hanging there have a 5-gram mass, not weight, mass. They are charged equally by a charge of Q, and they suspended along the threads. Read your question nicely so that you can know what's going on before you start doing it. So we have the one going that way, and we have the other one going that way, and they're telling us the angle. So if you draw the vertical line between them, we know that this angle here is 20 degrees, and this angle here is also 20 degrees. This one has a charge of Q, this one has a charge of Q, and they tell us that it's 5 grams each. They want to know the charge on Q is our final question. Where do you think you're going to start? Think about it. Think. Yes. Say again? Definitely. Let's do that because that's the easiest mark to get. Well done. So you're going to say that the mass is equal to? Yeah, but what did they give you there, guys? They gave you 5.0 grams. So what are you going to do? You're going to say 5.0 times 10 to the minus 3 kilograms.
Is it 10,000, man?
Yes. Divide by 1,000. If you're saying 5 grams is 5,000 kilograms, I'm hoping that it's going to scream at you in the exam. Okay. If you know how to do this on your calculator, do it on your calculator. Guys, just don't do it wrong. If you're going to times by 1,000, you can never think that 5 grams is going to be 5,000 kilograms. That should really blow a whistle in your brain when you see that. Okay, so that you'll get a mark for, so definitely do it first. And then this is not a force, so then we know that if we want the weight, which is equal to Fg, then we're going to have to say that it's that whole value. So it's the mass times by G, remember? So that is going to be 5 times 10 to the minus 3 times by 9.8. That will give you your weight. Do it because you might need it and that would give you a mark. 0, 0. It's not your final answer, so rather leave it like this. Guys, don't round off too much. Rather leave your in-between answers like that. So that will now be newtons. Okay, so even though we haven't actually realized what we're going to do to solve this problem, if this was out of 5, we already got 2 out of 5. So this is good. Do the stuff that's going to give you marks, even if you don't know how to do was it the bell?